My name is Saim, and I'm the professor and also the CEO of Sanyou London. And the topic of the presentation, first of all, I want to thank the organizing team, Ms. Sorcha and yourself, the whole team, for organizing this beautiful conference and inviting me for this honor. The topic is vacuum insulation energy technologies for realistically reducing heating or cooling energy requirements in buildings. Uh, my aim, being in academia for decades, it is important for me to understand what is the purpose in academia. Well, most of the time we spend time on research, writing papers, and publishing articles and etc. But there is a significant gap in the academia, especially in the United Kingdom, where you have only papers but no products, no manufacturing. So my ambition has been to conduct the in-depth research and development and utilizing my knowledge, expertise, and to divert them into industrial manufacturing and then produce a product where the consumers can actually benefit from. Uh, Sanyou London Vacuum Insulation Energy Technologies is the collaboration between China and the United Kingdom. And as we know, that China is the world leader in manufacturing, in high quality products, materials. So there has been a good collaboration, a positive collaboration with the manufacturers in Changzhou. And I had a very great relationship with them. And also I visit a lot and guide the engineers as well. So Sanyou London is the organization in the United Kingdom in partnership with Jiangsu Sanyou in China. Now, this Sanyou London consists of three departments: the Department of Industrial R&D in Vacuum Insulation Energy Technology, Department of Products and Sales, and Department of Knowledge Exchange and Impact. The Department of Industrial R&D is all about conducting and producing new products that can realistically help in minimizing the energy consumption. We call it energy saving. Simple as that. There is no, complexity or some vagueness in it. So I have my own research and development facility here in the UK, and they have a mass manufacturing facility in China. So we collaborate, we produce products, test, analyze, work together as a joint team. And the Department of Products and Sales is another department which is all about producing the product to the market, to the people. So one of my innovation is vacuum insulation wallpaper. 2 or 3 innovations are still under patenting and under processing. So at the moment, I'm just going to talk about the major examples of this organization that consists of vacuum insulation wallpaper, decorative integrated vacuum insulation panel with flexible designs, and we have vacuum insulation bag or box or medical boxes, deep cold boxes, rolling card cover, and fresh pack. Now, I will not be talking about medical boxes because my focus on this presentation is all about buildings. We talk about net zero energy buildings, we talk about energy efficient buildings, we talk about sustainability buildings, then which means the technologies that I'm presenting in this presentation are only 3 of these. So the Department of Knowledge Exchange is all about educating and sharing the knowledge to the public and to the organizations and to the government agencies who can benefit by minimizing the energy consumption. But ideally, I always ask one question: what is the purpose? What is the future? So our future ideally is thinking and asking the right critical questions at the right time, in the right place, under the right circumstances, with the right inspiration. And now this never happens. Sometimes in in a multiverse, in a universe that could happen. But this is the direction. We have to ask the right critical questions at the right time. And I was fortunate enough to ask this question, okay, what is the purpose of this whole academia, this whole universities and all these things? Why we do research in any way? What is the purpose? If we don't produce a product for years, we get the research funding grants and we produce the reports and PhD students, researchers, lecturers, we hire them. But what is the end product? Ultimately, the end product remains in the paper, in a document. But there are some serious concerns. So we still have to ask the right questions, which is, what are the problems and challenges within the energy sector that we need to solve? And why they are not solved yet? For example, in the era of oil and gas, when the electricity prices were lower, now they are 4 or 5 times more than during the oil and gas boom. So we had the argument of renewable energy, net zero energy infrastructure, climate change. I understand that. I've been using these arguments for decades. And at some point, I just realized that these are just a punchline, not the solutions. So if we manage to solve the problem with the renewable energy, which is the basically topic of the presentation, then why are these renewable energy technologies actually increasing the cost of electricity to the consumers, which is the pretty much evidence in the United Kingdom? Of course, this can be argued, renewable energy is good for environment, minimizes the carbon emission and etc. But at the same time, the amount of energy it takes to produce the wind turbines, the solar panels, and all of these renewable energy technologies, we ignore that. We don't consider that in terms of the whole life cycle of the product. But on the other hand, I also published a paper on carbon capture and storage technologies, which I'm sure that experts in oil and gas are specialists are already working on it and have produced significant progress on it. So carbon capture and storage can be a revolutionary idea to keep these natural resources in consumption. But are these problems actually solved, or are they merely an imagination? So we look at within the context of net zero energy building or sustainability or the punchline words, let's look at the real problems that the United Kingdom and European Union countries are facing, apart from all this political stuff. But the real problem is the UK and EU, European Union countries, energy crisis. We heard energy crisis 30, 40 years ago. Throughout my life, I have heard about energy crisis because it has been always the case. But this is real because the UK, the United Kingdom country as a whole, is facing a cost of living crisis. It is also because of the energy prices being increased. Now the winter is coming, they increase the energy prices again, the standing charges, the unit rates. Now these are the figures that I did not produce. They are produced by the Office for National Statistics in the United Kingdom. But many of my colleagues told me that people at the elderly age spend time in churches, trains, and on vehicles to warm them up themselves. And this is a problem, especially when we live in this 21st century where people cannot afford to heat up their homes. Now, this is a problem, needs to be solved. And it is a problem to ourselves, to everybody, to all the researchers and all the public people. The second problem we have in the United Kingdom is the houses. Houses are not insulated. We know this for at least 20 years. People and many academics, including myself, have been working on this, talking about this in the conferences and presentations, but it was just a talk. There was no solution. There's no practical solution other than selling the expensive heat pump technologies, or but still people cannot afford to insulate their house. That's the reality. And this reality is not produced by myself. It is the, again, official number that about 49% of the houses in the United Kingdom are not insulated. And what happens? Well, you don't need to be a building physicist or expert. You just understand that if the house does not have adequate insulation, the heating loss in the cold arid countries such as United Kingdom and European Union countries will be higher, which means you have to switch on the heating system longer. If you do that, your bill will be higher, electricity bill will be higher, and gas bill will be higher, and you would pay more money to the energy companies. And the whole argument is about minimizing the energy consumption. That's the simplest possible way we can put it. The third problem we have in the United Kingdom, I'm not sure about European Union countries, but I'm sure that they also have a similar labor shortage in construction sector and the building sector. But in the United Kingdom, we certainly have this problem that if you want to replace a window, if you want to install insulation, the cost of the product is actually less than the cost of installation because of the shortage of the constructors and the cost and the time and the disruption that it creates. So if you ask anyone to install the insulation or loft insulation, first they have to install the scaffolding and all. It takes weeks and then months, and then the installation cost and the cost of the product and the disruption it would cause. People end up not insulating their house. That's why we have a 49%, which is roughly 50% of the houses in the United Kingdom are not insulated. So everybody is aware about, even the ChatGPT knows that if you insulate the house, you reduce significant amount of energy. 30% energy, 40% energy, percentage varies based on the houses. But that saving can be useful to climate change, to global warming, and to all of these, punchline words. So I invented vacuum insulated wallpaper, a DIY, do it yourself, which means, well, what is vacuum insulation wallpaper? Well, vacuum insulation means that you reduce the heat transfer by convection and conduction when you evacuate the space or when you remove the air molecules from the space. So you have two sheets, and in between there's a fumed silica or fiberglass material, and then you install the getter that constantly maintains or absorbs some minute level of air molecules over the period of time. So what happens is that vacuum insulation wallpaper, which means my idea was that if you have that, which means I can install it, anybody can install it. You don't need any building contractors to insulate your wall. Then the second question came that what is the performance of the vacuum insulated wallpaper? And these are not simulation numbers. So these are practically tested industrial standard and verified performance in terms of thermal conductivity. So thermal conductivity means that lower the thermal conductivity, better the insulation. Higher the thermal conductivity, lower the insulation. So vacuum insulation wallpaper has approximately less than 5 milliwatt per meter per Kelvin. And in this presentation slide, you see the three possible effects, means the beauty effects white brick effect, yellow mesh marble effect, and oak wood effect. But there are at least 30 effects that I have approved and produced on sanyoulondon.com website, where people can choose whatever the type of the wall they want to feel comfortable with. Again, it has multiple benefits. One is that it can be done yourself. Second, it provides insulation, saving energy realistically, which means heat loss will be minimized through the walls and through the roof. And so that's the second benefit. Third benefit is you don't need this kind of old traditional method of coloring the wall, with paintbrush and this whole disruption that it causes. But also, it provides the new way of seeing your room. When you enter into your room, you want to feel comfortable and you want to feel energetic. So every person has a different taste of coloring in this 21st century. So we don't live in 1960s where you have to choose off-white color or light blue or some other colors, but you can actually choose a more vibrant or different dynamic color patterns. Now, of course, when it comes to the performance, vacuum insulation wallpaper, it has 5 milliwatt per meter per Kelvin. Now, if we ever compare with any of the existing insulation materials, such as PIR, insulation board, wool insulation board, mineral wool, EPS, XPS, and other thermal insulated wallpapers, which are typically available in the market, vacuum insulation wallpaper outperforms all of it. However, vacuum insulation every technology has its limitation. So vacuum insulation wallpaper, one of the things that I mentioned in the website, Sanyou London, which has FAQs in it, is it is sensitive. You can't drill hole on that. If you want to do that, then you have to give up one slide or one disc or one tile of wallpaper or VIW. So there are some limitations, but of course, when it comes to performance, and my ambition is to minimize the cost as well. So if I want to insulate the whole room or house or building, my aim would be to minimize the cost. And this is one of the ambition as part of the collaboration with the Jiangsu Sanyou in China, is that we improve the performance, but we minimize the cost as much as we can. So let's suppose you have a white brick effect. So what does it mean? I mean, how does it look like? Well, your room can look like this, or your dining area can look like that, or your, the lounge may look like, have a different view, and your kitchen might look like this. We have a yellow mesh marble effect. Now, another thing we talk about in the insulation world is about fire. Now, fire is something very, more we talk about the fire, the lesser it seems, because in the UK, I mean, we recently had a fire in the buildings, 2 buildings in London. We had before 7 years ago, we had a fire in Grenfell Tower. Similarly in Birmingham. So fire is the most common problem in the United Kingdom. And the reason of the fire is basically, there are many reasons we can talk about, but fundamental reason is the material we use. The XPS, EPS, expanded polystyrene, these are all styrenes, which are a form of polymer, and everybody knows that the plastic burns at a higher rate. But of course, you can do a treatment in it, but that treatment may not last longer after 5, 6 years or 10 years. On the other hand, you have the vacuum insulation wallpaper, which it cannot burn, which minimizes the spread of the fire and has a rating of A category, fire rating A category. Most of the EPS or XPS, which are thicker and difficult to install, require installers, but this one can be done by yourself. And this is my mission, that if domestic people, the normal people who are paying the bills, if they can actually minimize their energy bills by installing the vacuum insulation wallpaper, that's the real service to the society. And I thank always the leadership in China, which are constantly manufacturing new technologies and helping the whole world. The third effect is the oak wood effect. Some people like to feel more natural than it is possible. You cannot do that with coloring. It is only possible that new shapes and new designs can be done on the vacuum insulated wallpaper. So it is completely customizable, and it is available in a 200 by 200 millimeter size, because if one side damages, the other side remains as it is. So there's a whole discussion on that in terms of the dimensions and the design on sanyoulondon.com website. The second technology, which is a decorative integrated vacuum insulation panel. Now, again, we talk about the fire in the buildings and the weather conditions, the beauty of the building. So if you ever know the beauty of the buildings, you just have to visit England. And in England, all buildings, typically the houses are the same, having the same exterior. You see the yellow brick, oh, sorry, not yellow, but red brick. And that's it. And you got the roof, and all houses are the same. But if you visit Amsterdam, or you find different colorful buildings, if you visit China, Beijing or Shanghai, you find fantastically beautiful buildings with the different exposures. If you visit Dubai, or even if you visit Saudi Arabia and other progressive countries, you will find the buildings are being progressed to a very optimal look that people feel comfortable with. Now, there are psychologists who say that if your buildings look nice, people are more motivated. If your buildings are depressive, dark and gray, such as in Scotland sometimes, also lived in Scotland, so it's always dark and gray. So it's not really motivational. So decorative integrated vacuum insulation panel provides different exterior looks. Again, fire rating A category, which means it does not spread the fire. It does not allow the fire to go through it because of the vacuum insulation, and then because of the construction of it. So the decorative integrated VIP comes in two categories. One is the mid-century modern, which has a more brick effect or different textured effect. Another category is the metal type, which has a more shiny, beautiful appearance, such as dark yellow or gold or gray or etc. So, but it's not only about the look, it's about the insulation itself. So for a larger building projects, construction projects, it is important that people, well, they do spend time and construction cost increases because of the cavity wall insulation. So what we are saying is that instead of a cavity wall, you can have a structure, but you have a complete decorative VIP panels outside connected to as an external wall. It is a windproof, wear-off proof, and dust-proof, and also it is a fire-rated A category, which means it does not allow, and more importantly, the thermal performance. So when we talk about the performance of a decorative VIP, again, the thickness of the decorative VIP is not 4 millimeter, it's 30 millimeter. And this 30 millimeter is because of the different layers sandwiched together to protect it for a longer time, at least 20 years. Now, if we compare, again, there is no comparison because decorative VIP is 30 millimeter, has a thermal conductivity of 7 milliwatt per meter per Kelvin. If we ever decide to compare 180 millimeter PIR insulation board, which are still being used, being installed in the buildings, has a thermal conductivity of 22 milliwatt per meter per Kelvin. And now everybody knows that 7 is much better than 22. Similarly, we also have rock mineral wool, which is good fire-rated material, but again, you need 250 millimeter thick material, which means that consumes the space and the installation, the structure, and all of these complexities involved in using rock mineral wool as an insulation. But when it comes to the thermal performance, the heat loss or cooling loss, again, the performance 34 milliwatt per meter per Kelvin. Similarly, we have plastic materials which are still being used as an insulation. People install them as external wall, XPS insulation board or EPS, and the problem is that then when the fire occurs, the whole building burns. There's no minimum possible mechanism to protect it. So EPS and XPS, I'm against that. And glass mineral wool is actually good. But again, when it comes to the performance and the thickness, decorative VIP actually performs much better. Now, these are the numbers, industry standard, well calculated with certifications, and all of the work is being done behind it over the period of years. Now, MCM, we offer different types of textures, but MCM typically consists of the front layer. Front layer can always be customizable. You want a red, off-white, or different textures, wood effects, and etc. You can customize it. And then you have a calcium silicate, which is weatherproof and that provides structural integrity to the vacuum insulation panel, which is at the middle. And then you have a calcium silicate layer that can be used on the wall with anchors to support it. It's the easiest possible construction with this compared to the cavity wall insulation. And on sanyoulondon.com website, you will find the different the numbers and different categories that we offer to the customers for people to actually invest in achieving the net zero energy building. If you want to achieve net zero energy building, you cannot overly rely on solar panels or wind turbines or portable wind turbines. You got to minimize the heat loss. If you generate too much and your heat loss is there, then it's not effective. So, and this is one of the finest textured MCM type decorative VIP. And this is a wood effect that looks like a wood, but it's actually well protected as a layer. And then you have off-white and you have a light brown and different textures. But more importantly, people always ask that with the decorative VIP, is it possible to have electrical connections or gas connections? Yes, we do offer the hole in the VIP or decorative VIP. So as you can see here, there's a switch that was installed without losing the vacuum in it. So vacuum is very sensitive. So it is possible that with the customization, we can offer the holes for particular size of the holes for the gas pipelines or for the electrical wirings and etc. And it's also possible that we have the curvature or the arc style panels that can allow to have a circular type of buildings. And that's another type of innovation we have done over the period of years. And these are the just finishing and the realistic images of the whole showroom where we installed this decorative VIPs. The second category is the metal type. Now the metal type again that looks good, and when it's a sunny day, the buildings shine. We typically find this in a very rare buildings in London, but mostly in Dubai or Beijing, or maybe in European Union countries, but very rare. But it's not always about the look, it's about the vacuum insulation, it's about the protection, fire rating, the long-term stability that we provide, over 20 years of stability with certifications, and everything is well organized. That's what is important. That's what we do in academia, to make it everything well organized. Well, what it consists of, it is the same thing, except now you have the front layer as a metal layer with a nano coating that can also minimize the dust accumulation over the period of time. And now the details are on Sanyou London website. Again, that comes with a variety of textures, palettes, color palettes for metal type decorative VIP. But typically we offer at the very first stage, to make sure that it has a nano coating and it has all the safety features in it, as a 1 or 2, or what we call the yellow or dark yellow or the dark gray. Now, of course, it's a dark gray, but when it's sunny, it will shine. So, but gray is not something that I like, but these are available depending on the people's preferences. Again, as you can see, the switch is being installed through the decorative VIP, and that means there is a hole in it which is being manufactured at the production stage. So you can't drill the hole after the installation. It has to be well planned before that, so that because if you do that, then you lose the vacuum in a particular slide or particular tile. But you will not lose the whole vacuum of the whole building, just a particular tile, if you ever try to drill the hole. Now, again, we need to understand experimentally the energy, thermal, and sound insulation performance. Well, we know this energy in terms of how much energy you save, and thermal in terms of what temperatures are inside and what happens if you switch off the air conditioning and how long it takes to increase the temperature, right? The sound insulation, we are well aware about the problems of a sound in cosmopolitan cities such as Rome or Beijing or London or New York, for example, in the United States. The problem, of course, those who live in city centers. I lived in a city center in London for many years, and I understand one thing, that in London, particular, the houses are not insulated at all. Even the type of glazings that uses is a single glazed, and the noise is a big worry factor in London, especially because I can talk about based on my experience. So vacuum insulation, on the other hand, minimizes the noise, and how much it minimizes it is what this experiment was done. So you have the house A, which was constructed with a decorative integrated VIP, and you have the house B, which is constructed with the homogeneous panel, similar size panels with the same thickness, but not vacuum insulation. So house A and house B, and then inside we install all the performance measurement tools and energy meters, and to measure temperature, humidity, and the air conditioning load, and etc. Well, the energy performance analysis show that the overall energy consumption of house A, which has a decorative VIP, is about minimum 22% lower than the house B. So in a particular time, 2-3 days or 4 days, you realize that, okay, there is a significant energy consumption reduction because of the vacuum insulation. And how it does it? Well, it does it with the temperature maintenance. So for example, if you switch on the air conditioning in a hot arid country, the cooling loss through the wall, or same as the heating loss through the wall. So if the cooling loss is less, that means the air conditioning load can be minimized. And that saves the energy bill. Simple is that. So the thermal performance analysis showed that the rewarming test shows after 6 hours temperature rise of house A is about 15% lower than house B. Now, thermal and energy is all closely related. So again, this experiment, industrial experiment, show that, you know, house A with the decorative VIP is much better than the homogeneous panels. But again, if I ever were to compare house A with the London house, it will be much, much higher, because even with the homogeneous panels, they are actually good compared to the solid wall houses that we have in London or in other parts of the England, including the one that I live in. The third one is a sound insulation. Now, sound is measured in decibels. So the experiment shows the, you know, the reduction about 15%, 15 decibel quieter than house B because of the vacuum insulation, and which is a good thing. You know, it's not the best sound insulation, but it is the sufficient compared to the other insulation types or other normal houses that we have. But of course, if we want to compare the sound insulation with the typical solid wall uninsulated houses in London, it would be quite a lot comparison. The third one is a flexible design of a vacuum insulation panel. Now, there has been an argument in the market or in the academic research that you cannot have a hole in vacuum insulation. Well, now it is possible. With the improved production and manufacturing, we managed to also create the hole in the vacuum insulation panel. But also we offer different sizes. Now the applications are in transportations, electric vehicles, battery compartments, electronic industries, and because of the flexibility or flexible design, it can be applied in a variety of applications. Wherever you want to maintain the temperature, or wherever you want to reduce the heat loss, or wherever you want to reduce the cooling loss, vacuum insulation panel actually outperforms the traditional materials. But of course, there's a major question always needs to be answered, which I have been trying my best to keep the cost of the products as low as possible, so that the people, the public, should benefit from it, and which I find that China is very good at it. But of course, when it comes to the VIP, well, there are many manufacturers in the market of the vacuum insulation panel. Why we are so innovative at Sanyou London? Well, we improve by incorporating new methods, new techniques, new IP protected materials that improves the performance. And what it shows that the Sanyou's at about 15 millimeter thick fiberglass VIP achieves the thermal conductivity of 2.5 milliwatt per meter per Kelvin, and 25 millimeter thick fumed silica VIP achieves the thermal conductivity of 4.5 milliwatt per meter per Kelvin. Now, again, if we were to compare with the other VIPs or vacuum insulation panels by other suppliers, don't want to mention the names, but They offer at 7 milliwatt per meter per Kelvin at 30 millimeter thick and more expensive. So in terms of the performance and the cost, these are the two major factors that we are hoping to drive towards the net zero energy or sustainability or climate efficient methods, whatever the punchlines we use towards that. And of course, if I want to compare 2.5 milliwatt per meter per Kelvin or 4.5 milliwatt per meter per Kelvin with 22, 34, 36, 44, well, it's actually no comparison with any other materials like, mineral wool insulation, EPS, or glass mineral wool insulation, etc. Thank you very much of your precious time of listening my talk, and would be happy to be contacted. You will find my details at sanyoulondon.com, but also my website, saimmemon.com, about myself, my history of contributions in academia, research, and my ambition now is to produce the realistic help to our society where they can actually minimize the energy consumption rather than giving them a research article. Okay, thank you very much of your precious time. Any questions you might have, you are most welcome to